Hello children, welcome to Standard 9 Science and Technology Part 1. This is the first module of the chapter Laws of Motion. The learning objectives of this chapter are to write equations of motion and use them to solve numerical problems, to obtain formulae by drawing graphs involving quantities such as displacement, distance, time and velocity, to verify the cause and effect relationships between motion and laws of motion as seen in various events of everyday life, to identify which of Newton's laws is being represented, to use Newton's laws of motion to explain the motion of an object. In this module, we will be learning about motion of an object, what is displacement, what is meant by distance, what are scalar and vector quantities, what is speed and what is velocity. Let us learn about motion of an object. Children, in which of the following examples can you sense motion? The first is you can see a bird flying. Now, second is there are some trains stalled at a workstation. The third example, you can see some leaves are flying in the air. And in the fourth example, there is a stone lying still on a mountain top. Clearly, we can see that the bird flying and the leaves flying in the air are the examples of movement. We can say that as they are seen in different position and different time, we can say or we can see the presence of a motion where the particular thing is absent. That is, we don't see any movement or change in location of the stone or the trains. So we say that they are not moving. Think about this. You are traveling in a bus and there is a person sitting next to you. So how do you see, is the person sitting next to you is in motion? No, you will see him or her at rest. Instead, you will see the things and people outside the bus are moving. So from this, we can understand that motion is a relative concept, that is, depending on where you are, says whether an object is moving or not. If the position of an object is changing with respect to its surroundings, then it is said to be in motion. Otherwise, it is said to be at rest, and it depends upon where you are. That is why motion is called as a relative concept. Now, we will learn about distance. What is a distance? Generally, if we say distance, distance is a numerical measurement of how far apart the objects or how far two points are. We are very much familiar about this picture. So this picture shows a random distance between 2 points, which is approximately 187 kilometers. It says how far two locations are. Or we can simply say distance is the amount of space between two places. The next concept is displacement. Children, we are learning about an object which is moving. Displacement means the shortest distance from initial position of an object to the final position of an object. In this picture, you can see somebody is batting a ball and someone is catching it. If you see, the ball travels a very long path, but if you see the actual distance between the batsman and the one who catches, it is very, very less. So displacement is this short distance. So here also you can see there are different paths to travel to school from home. If you see this blue arrow represents displacement. This green and the red one can be the distance. You can take any path to travel. Displacement is the shortest distance from the starting and the finishing point. What is the difference between distance and displacement? Children, follow the scooter. This scooter is traveling from point A to B and it is taking a zigzag path. If you see, you can follow this. This red arrow represents displacement where the blue line represents distance. You can clearly make it out. Distance is much longer and the displacement is the shortest distance between point A and B. Let us see one more example. The same way you can see an object is starting from a point or from a road here and it is traveling along the road. You can follow the green line which is the distance and the blue line which is the displacement. By taking the path, you can see the total distance traveled by the object is about 70 kilometers. But if you see, after reaching the final point, the displacement, if you calculate, it is very less, which is only 14 kilometers. If we calculate the distance between the starting and the finishing point, it is just 14 kilometers. It is the minimum distance. But if you see the actual distance covered, which is a long path, which is about 70 kilometers. So from this, we can understand the difference between distance and displacement. Distance is the actual path traveled, where displacement is the minimum distance between the starting point and the finishing point. From the above examples, we clearly understand that distance is the length of the actual path traveled by an object in motion while going from one point to another, where displacement is the minimum distance between the starting and finishing points. If you see, children, the displacement of an object can be zero, that we will see in the coming slides how it happens, but the actual distance cannot be zero at all. Children, now let us try an activity. Take this picture. This is Sheetal and Prashant's house. This is Sheetal's friend Sangeeta's house, and this is the school. One fine day, Sheetal went to her friend Sangeeta's house on her way to school, picked her up and then went to school. But Prashant went straight to school from home. Imagine both of them are walking at the same speed. Who will take less time to reach the school? Obviously, Prashant will take less time to reach the school because it is the displacement, that is the minimum distance between the home and school, which is 1300 meters. But if you take Sheetal first went to Sangeeta's home, which is about 500 meters apart, and then from there to school, which is 1200 meters. So totally they have to travel about 1700 meters. So obviously Prashant will be the first one to reach the school. Is there a difference between the actual distance and the distance traveled? Yes, obviously there is a difference. The distance traveled by Sangeeta is about 1700 meters, where the actual distance is 1300 meters. So there is a distance of about 400 meters between their travel. Okay children, think about this. Every morning, Swirly walks around the edge of a circular field having a radius of 100 meters. So this is a circular field with a radius of 100 meters. If she starts from the point A and takes one round, how much distance has she walked and what is her displacement? So here talking about displacement, since she is taking a round along the path and coming back to the original position, there is no difference between the starting and ending point. So the displacement here is 0. So at conditions where the starting and ending points are same, there won't be any displacement. Talking about the distance, so this is the perimeter of the circle. So we know the formula to calculate. It is about 2 pi r, and substituting r as 100 meters, we will find the distance travelled by swirly. Next, we have a car here. The car is starting from point P, goes to point Q, which is about 360 meters apart, and then returns to point B. And here, what is the distance and what is its displacement? Displacement, as we are talking about, since the car came back to the original point, there is no displacement, or displacement is 0. Distance, the car travels from point P to Q, which is 360 meters, and then from Q to P, which is again 360 meters. Adding these two, we will get the distance. Children, hopefully you have a clear understanding of distance and displacement now. Now it's time to learn a new concept called scalar and vector quantity. What is a scalar quantity first? A scalar quantity is defined as the physical quantity that has only magnitude. Children, we know the word magnitude means the amount or portion or proportion. So if there is something that we are measuring only the quantity, then it is called as a scalar quantity. It is just the value. Examples like mass of an object, the distance, time, speed, volume, all these can be measured just as a quantity, just as the amount. So all these are termed as scalar quantity. What will be a vector quantity? A vector quantity is defined as a quantity that has both magnitude as well as direction. Children, direction here doesn't means only the north, south, east and west, but also whether the movement is upward, downward, to the left or the right, everything has to be considered. If the quantity is defined along with its direction as well as its magnitude, then it is called as a vector quantity. Take for example displacement. Here we are talking about the path of travel from where to where. Then velocity, these quantities we will be learning hereafter. Velocity, acceleration, the position of an object, where it is, up, down, left, right, where it is. Then force, then gravity, then weight. All these are measured along with its direction. So all these quantities are called as vector quantities. Learning about motion of an object, we cannot avoid this term speed. What is speed? It is the time rate at which an object is moving along a path. It is an answer of how fast. It is a scalar quantity, means that we are going to calculate only the magnitude of an object. The speed of an object can be calculated using this formula, that is total distance travelled upon time required, which will give us the speed of the moving object. The next concept we are going to learn with respect to movement of an object is velocity. Velocity, if you remember, it is a vector quantity. It is defined as the distance travelled in one direction. So since it is a vector, we have to represent direction as well. In one direction by an object in unit time is called its velocity. The unit time can be 1 second, 1 minute, 1 hour, 1 day, 1 year, etc. depending on the quantity. If large units are used, even 1 year can also be used as a unit of time. If we are measuring the revolution of Earth around the Sun, obviously we will be using the term year. The displacement that occurs in unit time is called as velocity. It is a vector quantity and the formula to calculate velocity is displacement upon unit time. Comparing speed and velocity, the units of both speed and velocity are the same. If you see in the SI system, the unit meter per second is used, where in the CGS system, that is a olden system, it is centimeter per second. The speed can be related to distance, where velocity is related to displacement. If the motion of an object is along a straight line, then the values of speed and velocity are same. Otherwise, if there is a change in direction, they can be different. Velocity is the displacement that occurs in unit time. Let us understand more about speed and velocity using some simple calculation. We are taking the same old picture. We know the straight line distance between the house of Sheetal and Sangeeta is about 500 meter, and between Sangeeta's house and the school is about 1200 meter. Also, the straight line distance between Sheetal's house and the school is about 1300 meters. Take for example, Sheetal is taking 5 minutes to reach to Sangeeta's house, and then together they are taking 24 minutes to reach the school. What will be the speed of Sheetal along path A and path B? Let us calculate. What is Sheetal's average speed? First, Sheetal's speed along the path A, that is on her way to her friend Sangeeta's house, will be, we know the formula to calculate speed, which is distance upon time. The distance between the Sheetal's and Sangeeta's house is about 500 meters, and she is taking 5 minutes to reach her home. Using the formula, we get Sheetal's speed along path A will be about 100 meters per minute. What will be her speed along path B? Path B, if we take, the distance is about 1200 meters and the time taken by them is about 24 minutes. Applying that in the formula distance upon time, we will be getting 50 meters per minute. So, how to calculate average speed? To calculate average speed, we have to take the total distance travelled in total time, which will be 1700 meters upon 29 minutes, which will give approximately 58.6 meter per minute. This is the average speed of Sheetal. What will be her velocity? We know the velocity formula is displacement upon time. Children, the displacement, that is the minimum distance between Sheetal's home and the school, is 1300 meters. So displacement is 1300 meters and the total time taken by Sheetal is 5 plus 24, which will be 29 minutes. So applying this, we will be getting the velocity is approximately 44.83 meter per minute is Sheetal's velocity. So with this, children, you know how to calculate speed and velocity. Let us see the effect of speed and direction on velocity. What happens, how it influences. Let us imagine a boy called Sachin is traveling on a motorbike. What will be the effect of velocity of the motorcycle if the speed increases or decreases but its direction remains unchanged? Children, the velocity increases if the speed of the bike increases, and the velocity will decrease if the speed of the bike decreases even when the direction remains unchanged. In another case, there is a turning on the road. Will the velocity and speed be the same? No. Since there is change in direction, the turning means there is change in direction. Even though the speed of the bike is constant, definitely the velocity will change. If on turning, Sachin is changing direction as well as speed of the motorcycle. Here children, changing the speed doesn't mean increasing the speed, it may be decreasing the speed also. If there is a very narrow turning, obviously the traveler have to decrease the speed as well as change in direction. So what will happen? Definitely we will see the change in velocity if the motorcycle is turning with change in speed. From this, we understood velocity depends on both speed as well as direction, and it changes by changing the speed while keeping the direction same. By changing the direction while keeping the speed same, the velocity changes. It also changes when you change both speed as well as direction. Now, let us summarize the points we have learned in this module. We have learned that distance is the length of the actual path traveled by an object in motion while going from one point to another, where displacement is the shortest distance from the initial to final position. A scalar quantity is defined as the physical quantity that has only magnitude. Take for example mass and distance, where a vector quantity is the quantity that has both magnitude as well as direction. Example, displacement, velocity, etc. Speed is the time at which an object is moving along a path. It can be calculated by total distance travelled upon the time required. Velocity is the distance travelled in one direction by an object in unit time. It can be calculated as displacement upon unit time. The velocity depends on speed as well as direction. So it changes while changing the speed while keeping direction same, while changing the direction while keeping the speed same, and also velocity changes by changing both speed as well as direction. We will be learning more interesting topic in the coming modules, children. Until then, thank you.